Okay, I'm going to be working through some examples now that are coming from the worksheet on solving polynomial equations. Okay, I'm going to do them on the whiteboard though. All right, so here it says for the polynomial equation, one root is given. Okay. And then it says find the others. Okay. Let's see if I can get that out of the way. All right. So for the polynomial equation, one root is given, find the others. That's the first question. So this one, they're giving us a little bit of a hint, so that's going to help us. So this is problem number 1. Okay, so here's the equation we have. It's 3x to the third minus 8x squared minus 13x plus 30 equals 0. And then they do like this. Okay, so that's the given root. Okay, that's the given root. All right, so what this does is this prevents me from having to do the rational root theorem. So I'm going to put 3 in the box, and then I'm going to take the coefficients of the polynomial. They're already in order, and it went x to the third, then x squared, then x, then constant. So I didn't need any placeholders, and I'm ready to do my synthetic division. So I'm going to bring down the 3, and then I multiply. Then I add -8 and +9. I say integer mistakes are one of the biggest issues here, so make sure you use a calculator if you need to. 3 times 1 is 3, and then I'm going to add straight down. That's -10, and then 3 times -10 is -30, and I'm getting a remainder of 0. Right now, since this was to the third power, I know there are supposed to be 3 roots, okay, and then I have one of them. This is one of them. So that means there's just 2 others. So if I know that's one of them, then what I have right here is the way I'm going to find what the other ones are. Okay. And so you don't actually have to do the factoring part of it. I know this is the A, the B, and the C. Think of it like that, maybe, of the quadratic. Since this was to the third power, and this was really x minus 3, I know this is really leaving me an x squared. Now, just because we're new to this, I'm going to write it, but normally I don't write the actual factoring part when I do it. But I know if 3 is a root, that x minus 3 was a factor, and then division is how you figure out the other factor. All right, now look, a lot of the apps just magically come up with the other factor. And if you do that, you're not going to get any credit for this. So you have to really show how you figured out that other factor. So now at this point, what we would do is maybe give factoring a quick try. And then if it's too hard to factor or it's not seeming to factor, then we'd go on and use the quadratic formula. Okay, so you see how this is where the 3 came from. So now we're really at the point where we would try to factor this. Here, let me just factor it right there. Okay, so come in and see. And look, you know, if you're not the best factor in the world, don't worry. If it's taking you too long, just use the quadratic formula. So I may go ahead and do that. I think this one does factor, but you know, if you've tried a couple things, like say you put in a 5 and a 2 and it's not working and you're starting to get frustrated, feel free to just say, well, you know what, A is 3, B is 1, and C is -10. I'm just going to use the quadratic formula, okay? So let me do that over here so I have a little bit more room. Okay, so basically A is 3, and like I said, we could have persisted on our factoring to see if we could get it to work, but not everything factors. And that one's a little harder to factor because of the 3 out in front. So you might want to jump right into the quadratic formula. And remember, that's the formula that looks like this. All right, so in place of the B, we're putting a 1. A is 3, and C is -10, and all of that's over 2A. All right, so that's -1 plus or minus all over 6. Here we used to make some mistakes, but you might be better at that than you used to. So this is a 1. See how there's 2 negatives. So remember how that's plus, and that's 120. So I have -1 plus or minus the square root of 121 over 6. You know what? That's factorable. See how that's going to be 1 plus or minus 11 over 6. Okay. And that means one of the other answers is 2. And then here we get the fraction negative, 2 goes in there, -5/3. All right. So the answers to this one turned out to be 3. 3 was one of them, and then 2, and then -5/3. And it doesn't really matter the order. Okay. You just knew you were going to have 3 answers, and there they are. So just to recap, on this problem, they gave us one of the roots, which saves us a ton of time because we don't have to test a bunch of solutions to this. We know which one's going to work, and we could just go in there and do it. And then once we find one that works, we're ready to come in and work through the process. So what happened is we put the 3 in, and we wound up getting that it worked. And so then A was 3, B was 1, C was -10. So we wound up plugging all that in. Okay. And then we wound up getting -1 plus or minus the square root of 121 over 6. Oh man, I'm glad I looked at this again. See, going from here to here, I dropped the negative. I was just kind of recapping, and then when I went back, I caught that mistake. It's really easy to do. So this turns out to be really -1, which makes that +10. Okay, so let me fix this. I'm glad I looked through it again. Okay, so this is going to be really +10 over 6, which would be +5/3. And then that's really supposed to have a negative on it, which makes that -12 over 6. And -12 over 6 would actually be a -2. Okay. All right. So it's really easy to make sign errors like that. Just kind of check yourself. Go back and work through it and make sure you were right. And I wanted to go ahead and do that one the quadratic formula way because some of us really have a hard time factoring when the number out in front of there is a 3. In reality, it would have worked. It would have worked if I'd put the 5 here and the 2 there and made this positive and this negative. Okay. All right. So that's one example. Okay. Let me do another one. So let me get another clean whiteboard and let's do another example. This one's going to have a higher degree. Okay. All right. So what if we're trying to solve 3x to the 4th minus 17x to the 3rd plus 61x squared minus 73x plus 26 equals 0. Okay. This one's degree 4. That's telling me I should have 4 roots. Okay. Which means I need 2 nice ones in order to be able to get it down to just having linear and quadratic, degree 1 or degree 2 left. I need to find 2 good ones. They didn't give me a hint, so I'm going to have to do the possible rational zeros. So the possible rational zeros, rational roots, are going to come from the factors of the constant term divided by the factors of the leading coefficient. Okay. And so that's plus or minus 1, 2, 13, or 26. And down here, it's plus or minus 1 or 3. So good, you'll see how this works. So to get the possible rational roots, I set up this situation here. And then when I have 2 possibilities down there, I need to do 1 over 1, which would be 1. 1 over, or I'll do it this way, 1 over 1, and then 2 over 1, and then 13 over 1, and then 26 over 1. But then I need to also do 1 over 3, 2 over 3, 13 over 3, and 26 over 3, okay? And I need plus or minus on all of those. So I have really 16 possibilities. And sometimes I'm very unlucky and I can't figure out which one it is until I tried all of them, okay? So usually what I do is I just kind of get started on it. So we might have a lot of work to do. When I do this in class, I get all of you to help me. And so we're all testing different ones at once. But here's what you would do. So you got your possible ones. Now test using synthetic division. And I want to see this. So you can do it on scratch paper, but you want to also turn that in. You don't magically come up with the ones that work. We just were lucky on that one example. So I'm going to test 1. I'm going to put 1 in the box. Okay, then I'm going to put the coefficients of the polynomial down. Okay. And then I'm going to do that synthetic division process that we're now getting pretty good at. Okay. Might need a little calculator when I get to some of those bigger numbers. I don't know where I put your calculator. In my bag. Okay. And then you don't keep finishing the whole thing when you can tell it's not working, but I'm not so sure yet, so I'm going to keep doing it. Oh, actually, it does work. That's good. All right, so this one worked. Okay, but that's not enough. See how I have too many numbers down here? I don't have just A, B, and C. See, this right here, so far what I have is that the original polynomial can be factored into x minus 1 times 3x to the third minus 14x squared plus 47x minus 26. Okay, that's where I'm at. You know, I started out with the 3x to the fourth part. Just so you kind of get a sense of what we're doing. So see, I have to find another one that works. Okay, that'll be just an x or something to the first power, so that this one will be to the second power, and then I'll be good. Now, I don't normally show all that when I'm actually doing my work. So what I'm going to do now is from here, I'm going to start testing some other ones. So if we're going to be authentic about it, what would happen at this point is I would come in and I would try some others, like try 2. Okay. And then 47 minus 16. Okay, and see how I'm trying it from where I left off? That would be 62. Okay, that's not working, right? So that one didn't work. So then I might want to try like a -1. Okay, and I'm going to speed up the process more than it happens in reality. When you set up your next one, remember to use where you were at. Okay, and so you sometimes have to try a whole bunch of these, and you're not doing anything wrong. That's just part of the process. Okay, that one's not working. So, you know, you keep trying. And in class, I have everybody trying a different one, so we find it a little quicker. So it turns out, I think, let's try one of these fractions. Let's start with some of the fractions. And there's really not a good way to know whether the fraction's going to be it or not. Oops. I need to do it from where I left off. Okay, so I'm going to use the 3, -14, 47, and -26. So this is the process where you're just testing using synthetic division. I need 2 of them to work. Okay, so if I bring down a 3, you can use your fraction keys here if you need to. I'm doing -12 times that. Okay, so what would that be? Okay, that would be 939. Okay, and then when I multiply that by 39, that would be 20. Oh, yay. I knew it was one of those, but you would not have known. So you would have just been trying until you find one that works. So one worked. Now we found this worked. And then here we're down to a quadratic. We have the A, the B, and the C. Okay, so at this point, we could go in and we could factor or use the quadratic formula from here to get the other 2 solutions to this. Okay, all right, so you might want to go ahead and first see if you can get it to factor. Okay, one thing I notice is that 3 was common to all three parts, so I might factor that out. Okay, but once I do that, what I have left, I can tell can't be factored. There's no way to break up 13 and get a 4 in the middle. All right, so what we're working on right now then is we're going to work on letting A equal 3, B equals -12, and C equal 39, and we're going to solve using the quadratic formula. So we're going to plug in B, opposite of B, plus or minus square root of the B squared minus 4 times A times C, all of that over 2A. That's a 12 there and a 6 there. And then -12 squared is 144. And then I've got to do the 12 times 39. Okay. And that turns out to be just a minus because there's only one negative, minus 468. So let me keep going. And don't wind up knocking out the 12 and the 6 yet. You got to work under here first. So when you do the 144 minus the 468, you get a -324. Okay, so that negative should remind you about the fact that you could get an I. And then, so I know there's going to be an I. Now I'm going to take the square root of 324, and that's going to be 18. So this is going to be 12 plus or minus 18I over 6. And it shouldn't take very much to get you back up to speed on this, because we spent a lot of time on that at the beginning. And you need to be accountable for learning the earlier material. We can't go back to square one on everything, but you should get back up to speed pretty quick. Okay, so let's collect then what worked. Okay, so we didn't have any hints. So we found that 1 worked. Okay, 1 worked. We found that 2/3 works, but we kind of cheated a little bit. I cheated a little bit. Normally this process takes forever because you just have to keep testing until you find what works. So I had to find at least one more nice one, and I finally did. But you see the other 2 are imaginary. I would not have found them using the rational root theorem. Okay. And so this would be the solution. Those are the 4 solutions you would get. Okay. All right. Let's try another one. Okay, so with this one, I'm doing one that's cubic to start with. So you should be thinking, well, that's going to have 3 solutions. Oops, that's not the one I wanted to do. I changed it a little bit. This one is x to the 3rd minus 5x squared plus 6x minus 2 equals 0. Okay, all right, so no hint about what works. Okay. I have three roots, so I know I need only one nice one to work, but nobody gave me a hint. So the possible rational roots, this is the rational root theorem here, come from factors of 2 over factors of 1. Okay, well, I like that a lot better than the last one. So 2 only has plus or minus 1, plus or minus 2, and factors of 1 are only plus or minus 1. So you really only have 4 possible solutions, 1 over 1 or 2 over 1, and then plus or minus. So now you're going to test to find one that works. One of those that works. So I'm just going to start. Usually I just start with one end and keep going. Okay. And so I'm going to put the coefficients of these down. Make sure you include the sign in front of them. Make sure if there were a term missing that you put in a placeholder. And then I'm going to do my synthetic division process. Okay. And so that means it works. Okay. So now I can use the quadratic formula now. I can use the quadratic formula because I'm down to formula or factoring. to solve x squared minus 4x plus 2 equals 0. See how that's an A, a B, and a C? All right, looking at that, I can tell it doesn't factor. I can't find factors of 2 that add up to be -4. And so I'm going to go ahead and do the quadratic formula. So if you'll just allow yourself to get back up to speed on quadratics and then really get good at that synthetic division, it can be a pretty fast process. Okay, so we get 4 plus or minus the square root of 8 over 2. Don't forget you have to simplify that. So that would be 2 square root of 2. And then since 2 goes into all 3 parts, you wind up getting 2 plus or minus the square root of 2. See, this would become 2, this would become 1, and this would be gone. Okay, and that's kind of sloppy. Hopefully you can see it okay. I'm going to work it out on paper and submit it as well. Okay, all right, so that's that one. All right, let me go ahead and stop this because the video is getting long, and I'm